A baseball is popped straight up into the air and has a hang time of 6.25 seconds. Determine the height in which the ball rises before it reaches its peak. And I've given you a hint. The time to rise is 1/2 the total hang time. Now, there's two questions here. The first one is the height. And the second question is how fast will the ball be going just before it hits the ground? Well, let's see. So we are told that the ball does this in 6.25 seconds. Now that's hang time. But unfortunately, when we're doing phenoms, we need to know the distance from, or the amount of time from here to here. And so I need to divide that number by half. And so that is 3.125 seconds. Given that we're talking about the y-axis, first, the time has no direction, and so the time to fall equals 3.125 seconds, or the time to rise is 3.125 seconds. And I got that information once again from hang time divided by 2. Next is, I know that, at least in the y-axis, acceleration due to gravity is negative 9.8 meters per second squared. And then, do I know anything else about the baseball? Do I know its velocity right here? It is 0 meters per second. Now, if I kind of ignore this part of the diagram, that is a velocity initial. The unknown, the thing that I'm going to look for, is either height or velocity. So I'm going to divide my paper up into 2. When I'm looking for unknown, that's my distance in the y-axis. That's going to be in meters. And on my second problem, I'm going to be looking for velocity final, the point at which the ball hits the ground. If I'm looking for distance, the equation that I'm going to use equals distance equals velocity initial times time plus 1/2 acceleration times time squared. If I replace numbers for letters, I get the distance equals, the velocity initial is 0, the time is 3.125 plus 1/2 negative 9.8 times 3.125 squared all over 2. Now this all blows up, leaving me with distance equals negative 9.8 times 3.125 squared all over 2. If I simplify the top, I equals negative 95.703125 divided by 2, and I get a distance equals negative 47.8515 meters. Now this negative means that the ball is going down, but all it asks for is height. So, I can respond negative or I can respond positive. If I apply the correct number of significant figures, which is 3, I get 47.8 or 47.9 meters, depending on your rounding rules. The other side of the problem, if I'm looking for velocity final, the equation that I'm going to use is velocity final equals velocity initial times plus the acceleration times time. The velocity final I don't know, so I'm going to write it again. My velocity initial is 0 plus negative 9.8, and the amount of time is 3.125. Velocity final, the 0 blows up, and when I multiply this together, I get negative 30.62 meters per second. Once again, this negative means that it's traveling in the down direction, which is fine. And if I apply significant figures, I get negative 30.6 meters per second.